Hello and welcome back, welcome. I don't know which one. Okay, so this is our we go fully online, and let's head into it. Let's head into it. Okay, how are we feeling? Oh yeah, right. So we're doing nature of roots now. Nature of roots is going to be all about the discriminant, as we call it. So we're just going to go through 4 examples. Maybe you can hit pause, well, just make you pause. No, works like that. So let's say we've got this equation, and our key thing that we're going to be using is our quadratic formula. Now, if you're given this equation, and I'm going to turn it into an equation because it wasn't yet. So we've got x squared plus 5x plus 3 equals 0. Go for it. Plug it into your, just the first step of the quadratic formula. So what I mean by that is, you know that the quadratic formula goes x equals minus b plus or minus the square root of b squared minus 4ac, everything over 2a. So substitute your values in and pause straight after the substitution step. Okay, so you've got minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Now for this part of nature of roots, the bit we're going to be most interested in fact the only bit we're going to be interested in is this part over here, which is sometimes called delta, or the discriminant. Is that how you spell it? Hopefully. How are we doing on that so far? Okay, I was going to put a question there. I'm not going to, because I don't know what you'd respond. Be like, I'm doing okay, I think. So that's what we're interested in, and here's why. Let's look at our next part. So we go x equals. So what you're going to need to do for your quadratic equations or quadratic formula from now on is, I want you just to pause on this part here and put that into your calculator. So throw that in to go 5 squared minus 4 1 3, and what do you get? I get 13. And what we're interested then is, this is the bit that we're going to interrogate. What does this number under the square root look like, and what does it tell us? So we've got 13. Is there a nice, neat number that the square root of 13 can be simplified to? 13 might be feeling picked on, and it might be saying the square root of 13 is the square root of 13, and what a great number it is. But there's no integer it can be represented by. Square root of 13 is the square root of 13. Right? There's no way of simplifying it. It's always going to have a square root sign. It's always going to be a surd. So what does this tell us? It tells us that if we look at this, we're definitely going to have two solutions. X is either going to be minus 5 plus the square root of 13 over 2, or x is going to be minus 5 minus the square root of 13 over 2. There are two solutions. So first key bit is we've got two solutions. The second bit is that they're always going to have this square rooty sign, so they're going to be irrational. So we've got two solutions, and they are both irrational. What's a rational number again? Well, a rational number can be written as a fraction, where both numerator and denominator are integers. In other words, things like 3 over 4, minus 3 over 4, 7, because you could write it as 7 over 1, 0, because you could write it also 0 over 1. These are all rational numbers. These two numbers are not rational numbers because of this radical, because of the square root sign. Okay, so let's soldier on. We'll come back to see what makes that irrational versus, say, this one here. So again, I'm just going to turn it into an equation. Substitute into your quadratic formula and focus on what's under the square root sign. All we're interested in is this bit here, b squared minus 4ac. What does that become? Okay, so you've hopefully substituted in. You went b squared, 6 squared minus 4ac, which is 36 minus 20, which gives you 16. So we fill in the rest of the equation, that x equals minus b plus or minus b. B is 6. 6 just looks like a b. Everything over 2a. Then what we get, and I'll hit a nice pause for you in a second, is that we've got minus 6 plus or minus the square root of 16 over 2. Let's just pause for a second and take all that in. Okay, so the bit that's sticking out. b squared minus 4ac. 6 squared minus 4 times 1 times 5 gives us 16. Remember, this is the heart of what we're looking at. What is happening under the square root? What's special about the number 16? I guess there are lots of things that are special about it, but one thing that's special about it is that it's a perfect square. So if we kept on solving this, our next line would go, so x equals minus 6 plus or minus 4 over 2. So we'd have our two solutions. X equals minus 6 plus 4 over 2. Or x equals minus 6 minus 4 over 2. So x equals minus 6 plus 4 minus 2 over 2 is minus 1. Or x equals minus 6 minus 4 minus 10 over 2 gives us minus 5. There. Now, here's the magic. We had a perfect square over here. So that's quite different to what we had before. We had a 13. And when we had a perfect square here, we had still two solutions. Whoopsie, nice bit clunking there. So we've got two solutions. And each of them happen to be integers, but they'll definitely be rational numbers because they'll definitely won't have that square rooty sign. So we've got two solutions and they're both rational. And it's all because this 16 over here was a perfect square. So perfect square, two solutions, rational. So far, we've got two different options. Let's try a third option. X squared plus 5x plus 7 equals 0. We're focusing in on the b squared minus 4ac part. That's the bit that we're interested in, but in the context of the quadratic formula. So, as I whiz across the screen, substitute in your values and tell me what you notice about the bit under the square root, the discriminant, b squared minus 4ac, and like how do you make sense of what answer you get there? Okay, so you put this all in. You said something about what you noticed. Maybe you're like, I don't know what I'm meant to notice. I'm going to notice something when I read what you've written, right? And we've got b squared, 5 squared minus 4ac. Everything over 2a. Okay. So minus 5, or 2a, we know what a is, right? A was just 1. Minus 5 plus or minus the square root of something either over 2. And that's something either 5 squared. I'm going to do it in my head rather than the calculator, but calculator, go for it. 5 squared minus 4 times, well, this is 28. This is 25. So we get minus 3. Okay, so now we merrily go on our way and we say, so x equals minus 5 plus the square root of negative 3. But hang on, and you may be repeating what you said earlier, but square root of a negative number? Question mark? That doesn't work in the real number system. Like, what's going to work? You can't have, like, let's say the square root of minus 4. It's not 2, it's not negative 2. In the real number system, I'll put that over there by the way. In the real number system, that doesn't really work out. So in this case, we're going to have no real solutions. Okay, so we had a negative number here. No real solutions. Real, because in the imaginary and complex world, there are solutions, but there are no real solutions here. Okay, ready for the last example. By now you must be like, ooh, come on. Okay, so x squared plus 9x plus 6 equals 0. Determine the discriminant. Remember, that's the square root of b squared minus 4ac. That's the bit we're interested in. Determine what that is and try and interpret what answer you get. Okay, so we're going x equals minus b plus or minus the square root of b squared minus 4ac everything over 2a equals minus b plus or minus the square root of, but this is the bit we're interested in, b squared minus 4ac. Okay. This is the wrong way around. No, this is the wrong way around. Okay, so cancel all of that. But at least I won't have asked you in the Edpuzzle. You've just watched me do all of this for nothing. This one's wrong. Okay, so pause and I'm gonna fix it. So watch it magically change. Did you see? Did it change? I'm interested what that looks like. So let's try that all again. X squared plus 6x plus 9. Okay, so in the context of the quadratic formula, where x equals minus b plus or minus the square root of b squared minus 4ac, everything over 2a. Right now what we're interested in is, what does this bit here tell us? So x equals minus 6 plus or minus the square root of everything over 2 times 1. Leaving you to fill in the discriminant, this part. Determine what it is, write that down, and try and interpret what that means. Okay, so let's try this again. We've got 6 squared minus 4ac. This is looking a bit better. So x equals minus b plus or minus the square root of everything over 2a. Okay, so 36 minus 36 gives us 0. So you've written something down and how you might have interpreted it. I wish I could tap into what that is now as I'm recording this, but I guess I'll get to it. So let's kind of carry on up here. X equals, oh wait a second, the square root of 0 is just 0. So we've got minus 6 plus or minus 0 over 2. Well, it doesn't matter if we add or subtract 0, it's just going to stay minus 6 over 2, so x equals minus 3. This is like the one we did in class already. We had x equals minus 3 or x equals minus 3. So our discriminant now, when it's 0, meant that we've only got one solution. Or, sometimes confusingly, we say we've got two equal solutions. Okay, so we either say that because of this 0, we either talk about having one solution or that those two solutions are equal. They're also definitely real, definitely rational, and there's only one. Okay, so quick recap. I'm going to scroll through it quickly, then I'm going to write it as a note in the puzzle. Nature of roots. We're interested in this b squared minus 4ac. That's the bit that's interesting us. And it's going to tell us what types of roots we've got. If it's not a perfect square, but it is a positive number like 13, then we're going to have two solutions, but they're going to be irrational because they're going to have these square root signs in them. If we have a perfect square, like here, this 16, we're still going to have two solutions, but this time they're definitely going to be rational because the square root part is going to kind of disappear, because the square root of 16 is 4. The square root of a perfect square will give us an integer. Okay. Option 3, this part's negative. So b squared minus 4ac is negative, which means that there are no real solutions, because in the real number system we can't take the square root of a negative number. And finally, if it's 0, then the square root of 0 is going to give us 0, like up there. And therefore we're just going to have one solution, or what's sometimes called two equal solutions. So we've got that down. Now what I want you to do, yeah, you're like, yes, there's more, can't wait. Now what I want you to do is, for each of these, we're going to draw what the parabola would look like. So I'm going to draw it over here. So we've got our x-axis, and we're going to run through this a bit more hastily. Is this a happy or a sad parabola? Definitely a happy parabola. How many solutions did we have, and therefore how many times does it intersect the x-axis? Two solutions means it intersects twice. There it is, irrational numbers. This equation, we've got an x-axis over here. Happy or sad parabola? Happy, positive x squared. How many solutions do we have, and therefore how many intercepts with the x-axis? Two solutions, two intercepts, both of them rational. Look, -1 and 5. Next one. Here's our x-axis. Happy or sad parabola? Happy, because the positive x squared. How many solutions did we have, and therefore how many times does it cross the x-axis? No solutions. No crossing the x-axis. There it is, not touching. Last one. Where can I squeeze it in? Up here. X-axis, that's an x. Happy or sad parabola? Happy, positive x squared. How many solutions do we have, and therefore how many times does it intersect the x-axis? One solution intersects once. Happens to at -3. So for your exercise that you need to do, exercise 2.7, page 50, question 2, you did that before, but this time I want you just to focus in on the nature of the roots, and for each of those draw a parabola. So remember, the parabola should be quite quick to do. Just an x-axis. Is it happy or sad? Most of them are happy. How many solutions are there? Don't even have to write what they are. Just, are there 2? Is there 1? Or are there none? That's it. Enjoy. Are you going to enjoy it? Enjoy.